Enjoy.
Thank you. Thanks, Cameron. Nice to be here. So it's the after lunch slot, so I'll try and keep it high energy and keep you awake. So first of all, thanks, Cameron, for the introduction. A disclaimer, I am actually not a tester. I actually was a developer, so don't hiss and throw things at me. You can if you want, but make sure they're soft. I originally was a developer. I learned to code at the age of 10, and the applications that we have as a company, I first wrote myself, and now we have a whole team that takes my awful code and makes it good, and we have quality engineering and lots of good practices. But that was my background, and I actually started the company because I found in my old job as a consultant, we never had good tools for testing. The developers had all the good stuff. And so as I became a project manager managing a team, that's what inspired me to start the company and build quality tools for testers. So although my background is development, I appreciate the fact that testers historically have not had the same love and attention that developers have. And that was sort of the inspiration for starting the company. But that's enough about me. Today we're going to talk about risk-based testing and artificial intelligence. Who here has experience with risk management? Raise your hands. Good. Risk-based testing? Excellent. So for some of you, this may be a reprise. Other things may be new. So I'm going to try and bring everyone up to the same level. This is a completely tool-agnostic presentation. Everything you see here today, you could do in a spreadsheet, online. No tools needed. You can do it yourself. There are some screenshots from our tools, but that's, again, just because that's what I had. So we're going to talk about what is risk management, what is risk-based testing, how you can use some techniques to improve your test planning using risks. And then at the end, I'm going to be talking about artificial intelligence and how that's changing the landscape of risk management and changing the landscape of testing, how it's adding risks and maybe reducing risks. We'll see. And this is a very moving target. This press has been updated several times in the last few weeks even. So first of all, what is risk-based testing? What are the types of risks? How you use them in your test plan? How you can prioritize your testing using risks? And then AI and machine learning, and then questions if we have time, hopefully. So first of all, what is risk-based testing? Well, it's a method which uses the probability of risk to determine where to test, how to test, and what to test. Very simple. But first of all, let's talk about risks. Because everyone, I think, understands issues. People always have issues. But risks are a little more of a fuzzy concept. So risks are basically a future event. So it could be you win the lottery. It could be that lightning hits your data center, and there's a catastrophic explosion, and the roof caves in, and all your servers are destroyed. Who knows? And in fact, winning the lottery can even be a negative risk. Most people who win the lottery end up broke in 3 years, so maybe it is a risk. Risks are generally negative, but they can be positive. But we'll be focusing mostly on the negative kind. Now, the key thing with risks is they're things that could happen, not things that have happened. That's an issue. So make sure when you're thinking about risks, however unlikely, it's things that are future-looking that you need to worry about. So when we talk about software development and building systems, there are actually 3 common risks that you have to deal with. First of all, conceptual risk. The first thing is, are we building the right thing? Like, I can build this great application, but if it's not what the users need, then it's not going to be successful. And conceptual risk comes in many flavors. I was watching on the plane over from America the movie BlackBerry, which is a really great movie if you ever get a chance to watch it. It's just come out. And it's about the launching of the BlackBerry and how they had to try and explain to someone at AT&T, a telecommunications company, what is a smartphone? Doesn't exist. And at the end, well, I won't spoil it, but at some point in the movie, Steve Jobs announces the iPhone. If you ever watched that presentation of the iPhone being released, he couldn't actually explain what the iPhone was. He had to introduce it as 3 separate devices, and then at the end, you realize it's one device, because people had never seen it before. So conceptual risk is really hard to mitigate, and when you're building a system, especially a new system, or it's a new use case that people haven't seen before, it's very hard to get right. The second one is technical risk. In the movie, going back to the movie example, they built a great smartphone, but when they put it on the network, it crashed the entire telephone network. And they had sold 2 million devices instead of 200 million devices instead of 500,000 devices, and it crashed the network. So even if the concept is good, technology may not be ready for it. So you have to prove out technical risk. And the last one, the risk everyone thinks about is, are we going to be on schedule or not? And I had a real example of this when I was building a system back in the US for a company called Sapient. You may have heard of them. We were building a system to run on the US Navy's network, and it was supposed to be used in combat and these crazy RF radios, which were like modems, like 200 baud or something. And so we built this software system, but we never actually tested it on the final hardware. We tested it in the lab on a simulator, and as soon as we put it on the real network, 6 months later, it didn't work. 6 months of effort wasted. So when we talk about risk, think about these are the kinds of risks you have to deal with. How do you mitigate them? Well, one way we mitigate risk is using Agile. So we talked about quality engineering and Agile methodologies. One of the main reasons we start to use Agile is not just to deliver things faster, that is obviously one of the benefits, but it's to reduce these 3 kinds of risk. First of all, conceptual risk. If I get to show it to you quicker and you try using it and it doesn't work for your use case, then we'll know right away to change that versus waiting a year to give you something that makes no sense. Technical risk. In my example, if we had tried that software on a real radio, do a very simple test, we would have mitigated the technical risk. And if ever you're doing an MVP, or if teams are doing MVPs as a tester, make sure that people are choosing an MVP that actually proves out technical risk. Too often we see people do an MVP that doesn't prove out technical risk, just feature risk. Like, does it have the right features? Does it have a single use case? But they're not testing out the most tricky things. So as a tester or as a developer, you have a responsibility to find the areas of technical risk and deal with those. And then lastly, of course, Agile helps with schedule risk because you're delivering in sprints faster. Now, when we talk about risks on a project, if you start to think about risks and risk-based testing, the first thing you have to do is figure out what risks you have. And one of the exercises we would do, hope you can see it on this screen, it's a bit bright, is come up with a breakdown of risks. Decompose all the risks you can think of. And your team needs to be creative. Like, people often say, I don't want to be the one who makes up a bad choice and says a risk that's stupid, I get laughed at and everyone's mean to me. So have a blameless culture. Make sure that there's no bad suggestions. And one of the games we would play at our company is we call it the least worst idea. So we start with the worst idea of why something would be no good, what risks could happen. The developer could have, I don't know, could code it in the wrong language. Or, I mean, you come up with just silly things that don't make sense. And eventually, as you start to get less and less ridiculous, you start to actually have risks that actually are possible. Maybe not likely, but possible. So have an exercise to identify risks. And again, there's no bad ideas. Everything should be on the table. Technical risks, people risks, training, schedules, skills, infrastructure, all of the things that you worry about, make sure you understand them all. Next thing, how do we quantify risks? Well, people always say, that's a really bad risk. That's a serious risk. Well, earlier on it was mentioned Prince methodology. If any of you have studied Prince 2 methodology, that actually includes a risk management methodology as part of it. And in that methodology, we talk about 2 main axes of risk. One is probability. How likely is the risk going to happen? And in this example, we've given it a score 1 through 5. 5 is it's almost certain going to happen. 1 is rare. And so if we think about the example of maybe lightning hitting our data center, how likely is that? I actually don't know. I'm not a meteorologist, but I bet if you look at your data center and you figure out the kind of building, what it's made of, you can get historical patterns of when lightning hits a data center in the geo. So whatever it is, you can quantify the likelihood. The second thing you want to figure out is the impact. Boom. How bad is it? If lightning hits something, how bad is it? What will it do? Will it just fry everything in the building? Will it do certain damage, other things? Whatever the risks are, quantify the impact and the probability. And the important thing here is to look at them separately. It's very easy, I think, sometimes to people to look at a certain risk and go, oh, it's really bad risk. I'm worried that we've got a memory leak, or we're using .NET 8 and 4.8, and it's got a memory leak, and it's going to be really bad. Whatever it is, don't try and quantify them together. Do it separately, because what often happens is you conflate the 2 metrics, and they are independent. There are things that are very likely that are not that serious, and there are things that are very unlikely but catastrophic. And we as humans often conflate them. So by forcing us to estimate them separately, you avoid that bias that we often have as humans. And then you put them on a scale like this. And this is what's called a risk matrix. And a risk matrix is really useful because what it lets you do is see the combination of the 2. And if my laser pointer works, that's a risk. So exposure is the measure of probability times impact. And we gave the impact a score of 1 through 4, and probability 1, 2, 3, 4, 5. So the exposure of something that is certain and catastrophic is 20, and the exposure of something that is negligible and rare is 1. So from 1 to 20, that's our range in the example I gave you. So what should I be worried about? Well, obviously, you should be worried about this, things that are going to happen and bad. So if you see a risk up here that's certain to happen and is catastrophic, you've got to deal with that right away. And people often focus on these areas here, these 4 quadrants. The problem is, I think as humans, we're often biased against things that are less likely. And actually, what I would say, the sleeping issues or sleeping risks are these ones here. Catastrophic, not rare, but unlikely and possible, these 4 here, these are the ones that will bite you. Because I guarantee you, your team has already thought of these. They're mitigating, they're dealing with them. These ones here, not so much. And so that's a big issue, is that people will often underestimate the probability of something, especially if it hasn't happened before in your team. You assume what's it called, hindsight bias and then confirmation bias. You assume that things won't happen that have happened. Okay, so now we understand what risks are. Next thing, mitigations. So mitigations are things that reduce risks. So, and typically a mitigation will reduce a risk either by reducing its probability or reducing its impact. Sometimes it does both, but not always. And if I go back to my sort of semi-facetious example of the data center, lightning hitting a data center, so how would I mitigate that risk? Well, one is I could have a second data center somewhere else. Now, that doesn't reduce the probability of lightning hitting the first data center, but it sure does reduce the impact of it happening, because I've got a backup. Everything's being replicated, you know, at AWS, snapshots, Azure, whatever it is I'm doing. I've got a strategy to assume that one will go down. And if you actually look at cloud platforms like Azure and AWS, that's kind of what they've done. They've said that hardware is fallible. We'll assume hardware fails. We'll build redundancy so when things fail, which they will do, the impact is moderated. If you've ever used AWS and an availability zone goes down or a virtual machine goes down, it comes back up right away, pretty much. It's amazing. And they've traded basically probability for impact. Now, the second thing is you could reduce the probability. And to reduce the probability of lightning hitting a data center, maybe you put a lightning rod on it, or you change the cladding or some materials. You can do something to perhaps ground it. I'm not an expert. Maybe a Faraday cage around it. But there are things you can do to mitigate the probability and things you can do to mitigate the impact. And you typically want to do both, and you may need more than one mitigation. Here you can see there's 3. This was a schedule risk. And so when you do that, you now will reduce the exposure. So by reducing the probability and or the impact, we go from, say, it was 12 exposure to 6. And if you go back to the diagram a second, what we've done is moved a risk from, say, here to here, or from here to down there, and that's called mitigating a risk. That doesn't mean you've eliminated the risk. In theory, you could, I suppose, make it almost impossible. Most cases, you're reducing the risk. That doesn't mean you've eliminated the risk. Okay, so that's risk management. Now, testing, where does that come in? How does that all fit together? A good question. So let's talk about testing. So first of all, testing is a way of reducing risk. So before we get into this example here, why do we test things? Well, we test things to reduce the risk in the system, to understand the technical risk and make a decision. We don't typically go live with bug-free software. Maybe we want to reduce the bugs, reduce the defects, but we'll usually go live with something that we know has issues in it, and we've decided that they're an acceptable risk of going live. Because in most businesses, if you go live with 0 bugs, your competitors probably release before you, and you're out of business. So typically, it's a trade-off that the business will make, and as testers and other technologists, the job is to basically provide a guidance to the person who makes the decision. We're going to go live today or next week or a month from now. If we do that, here are the risks. The old version has these issues, the new version has these issues. Our competitors are doing this. You give all the facts. You effectively identify the risks as a tester. You reduce them by doing as much testing as you can, and you will go live with a certain amount of risk. So risks are inherently part of testing anyway. Now, risk-based testing is the idea that what we'll do is explicitly look at the risks. So imagine we've got this risk matrix, and I've taken a subset, and I've sorted it by exposure descending. So the top risk is exposure 12, goes down to 3. Don't worry too much about what's written there. They're just examples. But the idea is that the exposure drops down. So what we could do is we could actually link our tests, automated tests, exploratory tests, session tests, whatever we're doing, we could link those tests to risks. Seems a good idea, because testing will find out if that risk is going to happen. We could do a test to see Well, we think there's a memory overrun, there's a performance issue. Well, we could test that. We could shift left. We could look at our build pipeline. Did the build pipeline run faster when they ran the unit tests than last time? Is it historically running slower? If yes, then maybe we have a performance issue. So we're identifying risk early. And then what we can do is we can actually take those risks that we identified with the exposure score, and we can map them to our tests. And these are just, again, a notional example. And imagine you did this. And again, in real life, there's probably 1,000 risks and probably thousands of tests. But if we identify the tests and the risks together, we can now see, well, imagine that we only have time to run 3 tests. We probably want to do the tests that mitigate the 2 12 exposures. So test case 1, 5, and 8, perhaps. So that's a very simple thing we could do. But oftentimes, life is more complicated. The other thing we could do is let's look at requirements. So think about user stories, requirements, features, epics, whatever you're doing. Well, those have a business priority. Someone has decided that this feature is critical to the business. It's a really important user story. It's the most important thing we have as a company. And there's probably a bunch of other user stories or epics, again, whatever methodology you're using, that may be lower risk, lower priority. These are not as important to the business. And so if this feature has an issue, maybe this is the main application homepage, every user is going to hit this page. Maybe down here it's the administration page. Yeah, we don't want it to have major problems, but we could probably afford it to be not quite as bulletproof as up here. So you can take the business priority of the requirements or the user stories, and we can then take a requirement, and then we can then link it to a risk. So if we have these risks, and these risks all affect the login page, if the login page, we'll talk about this in a bit more in a later slide, but if that login page breaks, we can't log into the system, that's going to block every single user. Those risks are probably really important. So map the risks explicitly to your different features and stories and epics. And sometimes you'll take a requirement or a story, you'll go, what are the risks associated with this? Other times you've got your risk breakdown that you've already identified, and now it's a question of going back. Now, you might say, well, what if I have a risk that has no feature? What does that tell me? Well, that's an interesting use case, because in some industries, if you're working in them, you actually have to have risks before you start requirements, before you start figuring out your needs. If you work in life sciences, if you're building a medical device or a software system for pharmaceutical companies, or if you're building an automotive system, say you're building the next EV or self-driving car for Tesla, under the rules for automotive systems and for life science systems, IT systems, you have to start with the risks first and then derive requirements. So you might find you've got a risk, there's no requirement for it. Well, actually, that means you've got a missing requirement, and that's a problem. So, for example, in the self-driving car example, a risk you might identify is a pedestrian crosses in front of you. It's called a hazard, and then you've identified, well, this self-driving car IT system has to identify the person and know to put on the brakes. And if you haven't got a requirement for that, well, then you've got a problem. So risks and requirements are both lenses you should look through your system and identify if there's a gap. If there's a requirement that's got no risks identified, you probably haven't understood the requirement. If you've got a risk that has no requirement, you've probably got an implicit feature that is needed but hasn't been declared. So again, it's a good check to make sure all risks have requirements, all requirements have risks. All right, and next we want to understand the impact. So as I said, if you've got requirements that have the biggest business value, and they're linked to requirements and they're linked to tests, guess what? Those tests that link to this important feature are probably more important, potentially more important. Again, it's potentially. The second thing is, let's look over time. If we've got flaky tests that keep passing and failing, that doesn't mean there's a big problem, but it means there's a possibility we have a problem, more likely. We had a real example of this. We had a unit test, just one unit test, that kept failing every other build. We have a CI/CD pipeline, runs every few hours. Every time we ran it, there's one test with 50% pass, 50% fail, roughly. Not exactly, but pretty much. And we're like, oh, it's a flaky test, comment it out, don't bother, don't worry about it. No, wait a second, let's not do that. Let's investigate. We didn't have a flaky test. We had a race condition. We had a race condition in our code so that when you ran two different parts of the calculation together, they run in parallel, and depending on which finished first, you got a different answer. And we sell testing software, in case you didn't hear that. And if testing software gives you different answers depending on you do it, that's not a good thing. And our users are testers like yourselves, and they tend to find those things. So if you have a unit test that is unpredictable, it means you need to dive deeper into that. Don't simply assume, like we might have done that, oh, it's a flaky test, just comment out. Because we had a flaky test too, and that is real. You have a test that has a timing issue. We had some tests that depended on the source code being initialized, and it took longer than we thought. And the code was fine, but the test was flaky. And that's often the danger is you think that's the case. So again, when it comes to risks, identifying a probability of a problem or the impact of a problem is really important. It doesn't mean it's going to happen, but it might happen. So we use that as an opportunity to dive deeper into our system, and we found the probability was correct. There was a high likelihood of a data error in the actual application. The other thing we found out is when people write parts of the system, so these are requirements, these are a number of defects, and what we found is oftentimes, if you've got a requirement or a feature that has a lot of defects, there's something that caused that. And the danger is if you just start fixing defects, you fix the symptoms of the problem, not the root cause. And one of the things that we want to understand is what's the root cause. And so we often found requirements that were not well defined, and we had tests and parts of the system that kind of smelled bad. And you often hear that thing that developers say, oh, that part of the system smells bad. And what that often really means is there's a lot of historical issues with that section of the system, either because it's complicated or maybe the requirements weren't written well or whatever it is, but everyone knows in the system, if you touch this thing, you've got to do a lot more testing than if you touch that thing over there. And so one of the ways of measuring that is if you have a lot of defects over time, if you tie those back to specific parts of the system, features, stories, whatever, where you're defining your system, components, then you will often find there's a probability of more issues there, more side effects. The example we often have is that we know the security part of our system is complicated. If you change one permission system, suddenly all the other permissions stop working, or I could do something, but now the negative case means I can't click on that button, it's grayed out for me. So we always know that some parts of our system, honestly, are just more fragile than other parts. And we know that intuitively, but a way of making this a quantitative measure is understanding defects and requirements and how they tie together. Think about, that's a way, especially when you have teams that turn over time, that institutional memory is often lost. A quantifiable way is historical defect density by requirement or feature. Another thing that's quite useful to understand the impact of an issue is, what are your users doing? This is a screenshot from Google Analytics. Anyone here not know what Google Analytics is? Okay, Google Analytics is a tool that you use to measure the user's impact on a website. It's used for search engine optimization, for making sure your website is crawlable. It's also useful by marketing teams to figure out, well, users come into the website and they follow this flow. It's still hard to see on this projector, I'm afraid, but there's arrows that show the percentage of users that go from page to page, link to link. Well, we had a situation where we have a help desk tool. It doesn't matter that really, but the key is there's a navigation bar on it. And the navigation bar is used to get to every other page in the help desk tool. And so our tester found a bug where the navigation bar didn't load. And our developers are like, oh, it's only a small issue on one bit of the system, which is a true statement. Our testers said, quite rightly, yeah, but you can't get to any of the system if it's broken. And it's a bottleneck. So if you find parts of the UI that are very, very important, if any failures occur there, they have a disproportionate impact to the rest of the application. There was an example I remember at a conference I was at where I think it was a pizza delivery service. They had some issue with the dispatching software that sent out the pizzas, and they didn't realize there was a bug with it. And they got to like 11 a.m., 11:30 a.m. in the morning, and suddenly no one in Seattle had ever ordered a takeaway pizza. And that was against all the historical business patterns. They tracked this every day, and they're like, is no one in the mood for pizza? Is it like anti-pizza day? And no, their system was down, but they hadn't realized. It was just one tiny feature, but it blocked their entire business model. And so if you see user flow is really important, because if users all channel through a part of the app, that part mustn't break, even if other things break, because that's an impact point. And the other thing is, if you make code commits, guess what happens? You change things, and when you change things, you break things, or can break things. So look for code commits. Go into GitHub, go into GitLab, whatever your tools you're using, find the code commits, see what was touched. And there are now some interesting AI tools that some other companies that we've talked to actually make that can scan your code. It's kind of cool. This is just manually, you can look at your commit library, look at what you tagged. You tag this commit with this feature or story. You can figure out what was touched. But there are some AI tools that other companies are building, which are kind of cool, which scan your code base, and they can tell you where you're going to have the most risk in your code base just from the commit history. And they look at the historical commit history, and they look at the historical test failures and correlate the two. Now, we don't do that. That's not something we do. But there are tools being developed, and people are trying this out using AI, and it's pretty interesting. I don't know yet how successful it is, but we're giving some of this company some of our internal anonymized data to see how it works. But the idea is, if you make changes to the code base, you introduce risk. Okay, so you put it all together. What do you get? Well, you get this. And this, again, is something you can do at home with a spreadsheet. Doesn't require any special tools. Basically, you take all the risks you've identified in the first part. When your teams come together, you figure out the risks. You've now mapped those to test cases, or again, different kinds of tests, automated manual, exploratory session, performance, security, all those different types of risk and tests, put them together, and then we look at our features. So imagine these were some requirements. We've got a business priority with them. The highest priority we've given a high color. The lower ones we've given a lighter color. And we looked at these number of defects. Well, guess what? This delete functionality, it's got a lot of defects. Maybe there's some foreign key issues, I don't know, but it's got a lot of problems over time. I think we should be careful with that one. And then we look at, in the last sprint, we made 20 commits to this feature and a much lesser number here. So you put that together, and what you find is, if you add it all up, and this is just, again, a notional example, those areas where you see red have higher impact and probability of risk. There's more likelihood that something could be wrong. It doesn't mean there is a problem. It just means there could be a problem. And if you have a certain amount of time, and imagine this on a much bigger scale, finding those and applying these numbers, you can basically say, well, if I only have time to run 5 tests, I could look at the ones in red, and then the ones in yellow, and then the ones in green. And again, obviously, in a big situation, it'd be numerical and calculated numbers. But the idea is you're taking risk, and you're identifying where is the most risk in our system across those different facets, putting it together, and now I can understand if I only have time to test or deep dive a certain part of the system, maybe I've got a smoke test or a rapid set of unit tests that cover the entire system, but I want to go deeper with the time remaining. Use that time to go into these areas here. I think, okay, before we go into AI and machine learning, any questions on any of that part? Okay. All right, let's go to the next thing. So how is AI and machine learning going to help or hurt us? That was kind of the thing I was thinking about here. And so first of all, if you actually look at the software testing industry, we are, and I'm speaking the industry as a whole here, we're trying as an industry to try and use AI to make testing more reliable. For those who do automated testing, one of the biggest challenges is maintenance. One of the biggest challenges is flaky tests and the return on investment. If you spend a week writing tests and they're broken in a day, then you've got negative ROI. So a lot of companies are looking to use AI and machine learning to try and optimize tests so they don't break. Things like automatically understanding the playback speed, or if an object's label changes or color changes, looking for minor changes that aren't failures and reducing the flakiness. The second one is the example I mentioned earlier, which is this company. It's called Angulon, and they're looking at scanning the code base and looking at test failures and correlating them together and determining if they can find systemic risk. And there's a few other companies doing this as well. So it seems like it's a very hot industry. I don't think any of the tools are on the market yet, but that's an area where a lot of people in the industry are actually making strides to see, can we scan your code base, look at your Selenium tests, your other automated tests, UI, API, and unit tests, and can I see, based on the code base change, when we change this, which test failed, do it enough times, and they believe they can identify for you which tests are going to break when you committed one line of code, in theory. Now, again, it's still being developed. Another example is security testing and hacking tools. Hackers are using AI right now to find vulnerabilities in systems. So rather than just simply launching an attack vector based on a standard set of vulnerabilities, they look at your system, they look at your attack surface, and dynamically change how they're attacking it. And of course, to fight back, companies are building security defense tools, like Amazon does this with AWS Shield, which actually use AI to look at the patterns of an attack and dynamically change the response. So we're in this kind of cat and mouse game on the cyber side. Now, number 4, I'm going to come back to with an example. I was playing around with this to show you what it looks like. It's kind of interesting. So can we use ChatGPT and OpenAI to do some of our grunt work for us? And it's not really, it's not testing, it's just autocomplete. So can we have an autocomplete to save us time? And I think we can, but I'm going to show you what it did. So it's interesting. And then the last thing is, if you look on AI systems, lack of interpretability is a big issue. So traditionally, you've got requirements, you've got stories, you've got users, you've got product owner, you've got a scrum master. The customer understands what the functionality is you're building. But when you've got an AI system that you've trained, what's the right answer? And there's a really serious example of this in the US. which has literally hurt lives, they built a system that would automatically determine the sentence that someone should have if they committed a crime. And their thinking was, judges and juries are generally biased. Okay, makes sense, they're human. And can we eliminate the bias in that process? So they built a model that would look at historical patterns of people committing crimes who'd been given a sentence and figured out, for this kind of person, they're more likely to commit a crime. That kind of person, they're less likely to commit a crime. They rolled this system out using an incomplete data set. It was called, I think, Compass. And they found, using the data sets they had tested it with, guess what? Minorities and people of color or people from poor communities were getting longer sentences than people who came from more affluent suburban communities. But it was an AI. It was a machine. It's infallible. So judges weren't questioning it. And it's still in use today. It's all, go search on Ars Technica and ProPublica. They've done reports on this. And that's just one example of an AI system that was given a small data set, trained on it, and then now is let loose into the wild. So but how do you test the requirements? They don't even know how, they don't actually know how the model exactly works. They just know that it generates these answers. So that's the problems we're facing. Now, there are some interesting solutions too. Can we have machines help us? One thing we can do is, when we think about risks, at the beginning I mentioned you can have a team brainstorm risks and come up with the ones that are maybe probable but unlikely. And people are good at coming up with crazy scenarios, but so are computers. So some of the AI models we've used can generate risks, and maybe when you use it, and I'll show you some examples of what it generated, maybe the risks are obvious. Maybe they're things I would have thought of, but maybe one of them I wouldn't have thought of. So it's useful to use AI not to do the answer, but it can suggest things that you might have missed, thought of. It's like the wisdom of the crowds. They always say that. Get a lot of people in a room who are smart, and you get a smarter answer than just one individual. Well, AI is kind of like that because it scans the whole internet. It's got a lot of data. It doesn't know the answer, but it can at least give you some thought-provoking ideas that you can look at and say, that's interesting. I didn't think of that. But the problem is, there's a thing called AI poisoning. I'm not sure if you've heard of this. AI poisoning is a kind of scary-sounding term, but what it is someone deliberately training the AI to do something bad. And of course, hackers are doing this. Nation-state actors, certain countries are doing this actively right now on both military systems and civilian systems. They want to bring down power grids. They tested this at a university, and what they did is they got a self-driving car, and by changing the what they fed into the camera, they were able to train it without any in touching the interior of the system, without any changes to the code. They were able to train the car to, instead of stopping at a stop sign, to think it was a speed limit sign and just slow down. And so this self-driving car had driven fine when it was given a certain amount of data through its cameras that had been designed to fool it. Over time, the model learned, and it drove right through a stop sign and would have killed a pedestrian. And there are other examples of people doing this, and they're testing this out. Now, these are white label hackers trying to figure out where the vulnerabilities on these models are, but it doesn't take much for a black hat hacker to actually do that for real. So there's big issues there with AI poisoning. It means poisoning the model, making the model do unpredictable, dangerous things. Okay, so when we put that together, how do we think about this? So the idea here is, if we imagine we have an AI model, right, that determines the risks. So the AI is going to generate a risk model for us based on its understanding of our system and how it could be used. And it can determine, maybe it can estimate some impacts and probabilities. Now, we also then need a human-generated risk model to understand what are the risks it hasn't thought of. So the idea is, if you have machines that can identify potential risks, and we as humans have identified potential risks, we're checking each other. And so a lot of what we may find is that we're not necessarily looking at a requirement and saying, how do we test this requirement? Because there is no requirement. It's a model that's learned. We're identifying the risks for that model based on its use case. So it's a self-driving car. We don't know how it's learned, but we know the risks. We've identified those, like pedestrian crossing in front of me, a car slowing down in front of me, the lanes. There's a whole bunch of risks we've identified. And so we're using risks to check the AI models as opposed to requirements or traditional tests. So you start with risks, and you use computers to check. And the other thing you could even do is have a second computer check the other one. A lot of times you have multiple computers, and they can independently check each other, but that doesn't absolve you from having a human who's identifying the risks and looking at the impacts and the probabilities and doing that checking. And in the end, what you'll have is mitigations that are suggested by the AI and mitigations that are suggested by the human, and you can cross-check them. So that's where we're basically, I think, going to be headed, because these non-deterministic AI systems are going to be very, very hard for us to know, test, and understand what is the right answer. And so basically, think of it this way. We'll have humans check the machines check the machines, and then machines check the humans, and machines check the machines. So it's like multiple redundancy. Now, as an experiment, I was playing around. I was bored on the flight over, and I was knocking about a chat GPT. I've got access to the OpenAI API, that's a mouthful, and I was trying out different prompts. And I said, and this is an example, this is from our system, but again, that's just because that's what I had. I gave it one line. I said, well, I want to log into a web application. Okay, standard user story. It might be, as a user, I want to log into a web application, or I want to, log in. I said, that's all I gave it, just nothing else. And I said, write me some test cases for that. I came up with these. And without anything other than that one line, it said, verify that a user can successfully log in with valid, log in without entering a password, without entering a username, and then invalid. So the 4 use cases. Now, and this isn't rocket science, but I was showing our QA manager. He's like, when I have a user story, I have to go write this. I have to get a spreadsheet, or I have to type them in. And he's like, this is a good time saver, because guess what? I would have had to have done that manually. And this is all from OpenAI. It added that automatically. It automatically added some test steps and said, verify that you can log in. That's what the expected result would be. And it even gave you some sample data. Now, it doesn't know our application. In fact, that's not a valid login or password at all. That wouldn't work. But again, it's suggesting me a nice template, time saving. It's not solving it for me, but it's making sure I didn't think it missed something. And then we also asked ChatGPT, and this is the one that kind of blew my mind. We asked it to generate all of the technical and business risks to do with that one line. So we gave it the prompt, ability to log into the application, and we told it generate all the technical and business risks. And we could have it do more than that. We could say, what are the security risks? What are the performance risks? We just said technical and business, nothing else. And it came up with this list, and you can see it. It said, what are the legal and compliance issues if the login process does not meet the jurisdiction? User dissatisfaction if the login page is unusable. Maybe there's SQL injection. Maybe there's performance, compatibility across browsers and devices, and maybe a security breach because we know it's a login system. And again, I bet we all would have thought of some of these, but maybe we would have missed a couple. And this is a trivial example. It's a login page. But imagine it's a more complex app. So it was interesting to us just literally how it could generate useful information and save time and not necessarily replace the work we're doing, but help us think about things in different ways. And we could then have a separate team of humans take that exact same example and come up with the risks, the tests, and then compare the two, see what the difference is. But for me, it was interesting to see what it could do. And this was literally like a 10-minute example. I knocked it up again on the plane, didn't spend too much time. With a lot more time and sophistication, I was showing this to a demo. I was showing this at Star West last week, and someone in the audience said, "Hey, what if you, instead of just looking at these risks or these tests, what if you asked it to do functional tests? What if you asked it to do performance tests? What would it have done?" I don't know, but I bet it would have been interesting. So I think we're going to see these tools assist us. They're like autocomplete on a word processor. Like if you use Gmail and you say, "Dear Adam," as you type A, guess what? It says DAM, comma. You do RE, and it knows from my typing I'm going to end the word with regards. It's like that. It's an autocomplete. It's not intelligence. It's autocomplete. But guess what? Autocomplete saves time. So tools like this are going to be, I think, helping us understand requirements. Another thing I've seen a use case is taking a requirement or a user story and saying, rate it. How good is that user story? How good is that requirement on a scale of 1 to 10? And how would a computer know what's good? Well, for example, you might say, it can let you log into it. That's a requirement. You could also say, as a user who is a guest user, I can log into the web application and log in successfully. It's the same requirement, but much better written. I've defined the pronouns, I've defined the scope. It can read that and tell you how good is it. So there are definitely uses of these kinds of tools to help us do a better job, but they don't replace us. So, wrap up and final thoughts. A risk approach to testing is really useful, with or without AI. Understand the risks in your project. If you have risks without requirements, that's a problem. Requirements without risks, that's probably a problem too. Make sure you understand all the different kinds of risk, and you can start to use AI to help you, but know its limitations and what it is actually doing. And I think, with that, questions? Question number 1. Yes.